In the previous video, we talked about the measures of central tendency and how they are calculated. However, it is only part of the picture that summarizes the data set. Using central tendencies only can be misleading and thus not adequate. One needs to also know the extent of variability. And this will be provided by the measure of dispersions. Measures of dispersion describes how similar or varied the set of observations are for a particular observation. The three main measures of dispersion are range, interquartile range, and standard deviation. Firstly, what is range? The range is the difference between the largest and smallest value in a dataset. For example, let's use the monthly house rent data. Here the maximum value is $13,500 and the minimum value is $8,000. So range is equal to $5,500. Range is not a good measure of variability because it is based on two values only. Next, let's look at what interquartile range is. Interquartile range is defined as the difference between the 25th and 75th percentile, also called the first and third quartiles. It describes the middle 50% of values when ordered from lowest to highest. To illustrate this, let's take the monthly household rent data again. Step 1. Find the median. Here our median is 10,000. Step 2. Find the median of the lower half of the dataset, i.e. Q1 equals 9,250. Step 3. Find median of the upper half of the dataset, that is, Q3 equals 12,250. Step 4. Finally compute the interquartile range by subtracting Q1 from Q3. The interquartile range for this dataset is 3,000. Interquartile range is often considered the better measure of spread as it is not affected by outliers. Now, let's move on to the third measure of dispersion. That is standard deviation. An important characteristic of any dataset is the variation in the data from the mean. In some datasets, the values are concentrated close to the mean, while in some others, the values are widely spread from the mean. The most common measure of variation is the standard deviation. The standard deviation is the number that measures, on average, how far the values are from their mean. One important thing to keep in mind here is that the standard deviation is the square root of variance. So, how do we compute standard deviation? Step 1. Add up the squared deviations from the mean. Step 2. Divide the sum in Step 1 by n-1. Step 3. Take square root of the value from Step 2. And you get the standard deviation. For example, consider two sets of monthly house rent data. Here we can see that the mean for both A and B are almost same, but their standard deviations are different. This indicates that mean only paints a partial picture. To have a complete picture of what the dataset looks like, we also need to look into standard deviations. The larger standard deviation for dataset means that the values are more dispersed, as you can see from the graph below. So basically, smaller standard deviation means values are close to mean, and larger standard deviation means values are spread further from the mean. Finally, we can conclude that mean along with standard deviation is more useful than mean alone. So, having looked at all three measures of dispersions, which one is best? Well, if you use mean as measure of central tendency, then use standard deviation. But if your data is skewed, use median and interquartile range. And that is it for this video. I hope it was useful to you all. For more videos like this, visit our website at www.nsb.gov.bt. Thank you all and see you soon!